Thank you, sir.
That's cool that Win saved us 5 minutes of time. I think we'll use that straight away, and we hope to be in time for the next speaker as well. So we've got a challenge there. I was here in 2019, and it's really cool to be back on stage in person 3 years later. It's good to see that the room is very well filled. We're going to talk to you on offensive hunting and how we use blue team techniques to do red team ops. Because let's be clear, usually the blue teams are well ahead of us in structured way of thinking and how they approach their problems. So why not learn from the blue teams, as I hope that blue teams will learn from us in the end. First, a short introduction from myself. My name is Marc Bergman. I started in 1999 as a coder on mainframes. I wrote COBOL. Don't have gray hair yet. Well, they're starting to get there, but I started writing COBOL. Still regularly get called. Do you still write COBOL? Can we hire you? Because apparently there's a big demand. I didn't really like it, so I moved to offensive security in 2004, which puts me already up to 18 years of offensive security experience. At this moment, I'm working for Outflank, where I do red teaming. And with do red teaming, I mean we perform the red team itself, so we are hands-on keyboard red teamers, but we also talk to the business, do all the aftercare, so we talk to the blue teams. That's usually the people we hurt during the red team, and we try and make sure that they get the maximum benefit out of the red team. Because I think one of our main lines is that the blue team needs to learn from the red team, and if the blue team doesn't learn, the red team failed.
Yeah, okay. My name is Marc SMEETS, pretty easy, Marc. We're also colleagues of each other, so interesting discussions in team meetings, Marc. Going back, I would say I'm InfoSec class of 1998, hobby-wise, just poking around on the internet to see what's there. Professionally, 2006, when I graduated from university, I went to a big consulting and advisory firm, where I also co-worked with Marc. A lot of big fun, big clients, corporate, all over the world, advising. Back then it was still called pen testing, I guess, and nowadays we have got this brand new environment called red teaming, coupled with blue teaming, or adversary simulation, whatever you like. I'm a red team operator. I like to build all kinds of tools that make our life easier. I'm also a Vivid trainer. We have lots of trainings that we do. I really enjoy bringing that knowledge over to other people. And one of the stints that I did at a bigger bank and some other clients is jump from the red side to the blue side and just see how defensive units work and bring that offensive mindset to the defensive guys. And like Win said, we're not really into the blue versus red. We see this as one. And it's also one of the core values when, in 2016, when we were 2 of the 4 founders of the company called Outflank. We are an Amsterdam-based company solely focused on red teaming, doing offensive security or adversary simulation, whatever you like. And along the way, we also brought in some trainings, and we have a commercial offensive security tooling product. But the reason that we jumped on red teaming in 2016 is that the market was ready for proper adversary simulation. And we also find it very important to share the knowledge that we do by putting out the blogs, by doing out the research, by sharing code about proof of concept tooling, all kinds of stuff. By putting it out there, we help the blue teams to evolve as well. And you can go to the websites that are listed over there, and you will find all kinds of different tools. One of the tools that we have released, and I'm thinking in 2018, 19-ish, is called Red Elk. And that's one of the tools we'll be discussing in this presentation. It's a core aspect of our daily operations. Seems the reach is just a little bit short. Okay, thank you. If there's one thing that you are about to remember from this presentation, hopefully it is this. It's not red versus blue. It's together. It's sparring. It's preparing the blue team for the actual threats. The sole purpose of the red team is to improve blue. Yes, we do this by sparring. Yes, we do this with real punches. It really hurts when we're in operation and we get to do that strike. We also get hit back. But it's important to understand that the sole purpose is to improve the blue team. You can resemble this with sort of a sparring match. It's a core value of our company. It's not that we want to come along, smash the opponent down, get the goal, run away, and start laughing. No, it's about improving, both in operation as well as in documentation and reporting afterwards. Think of boxing. This is how our boxing ring looks like. It's a lot of stuff in there. I want to give you an overview of how our offensive infrastructure looks like during one typical operation. And we have multiple operations running in parallel. Just to give you an idea, we have multiple command and control servers coupled together with multiple redirectors or reverse proxies, something in between to hide RC2 server. We make use of domain fronting all the time. We create lots of fake identities, multiple different websites we create. We track with pixels everything, every email sent out, every action sent to our target, all kinds of different web servers, different delivery methods, and there are some back-end systems as well. One operation, roughly 30 infrastructure components. Multiple operations in parallel. This is becoming a problem in that sense, so we have lots of data to get track of. Now, let's jump back to 2018, when we released a tool called Red-Elk. Red being offensive, Elk standing for Elasticsearch Logstash Kibana. This was presented in 2019 as well here in Hack in Paris. I want to give you a quick overview of what the old tool or the old concept actually looks like. We have typical challenges, and the typical challenges can be divided on two aspects. We're having difficulty with having oversight and difficulty with having insight. Oversight as in 30 components per operation, multiple in parallel. It's just too much in that sense to keep track of every operational infrastructure component. If you look at an analogy, would be to, we're having difficulty managing the herd of infrastructure components. And if we have so many sensors out there on the internet, part of our operation, scans come by, but also blue teams start poking at our infrastructure. And this is where I want to introduce to you Mr. Edmund Locard, a French forensic science person. Back in the 19th century, he introduced forensic science. And he is most known for his adagium called "Every contact leaves a trace," the Locard exchange principle. If we have so many sensors out there on the internet, part of our operation, and it's technically impossible to do a contact to, well, on a crime scene, but as well as on a technical operation, it's impossible to not leave a trace. So that goes both ways. We, as offensive red teamers, we try to hack into a network. We cannot touch those systems without leaving a trace. And that's why blue gets triggered and try to find us and do stuff, get us out of there. The same thing applies the other way around as well. As soon as blue starts investigating, they interact with systems, they interact with our infrastructure, and they will leave traces. So this is where we start thinking, well, is there a way to have better oversight over systems and have better insight on what blue is doing during our operation? We are in that sparring match. We want to see that punch from blue coming before it's actually on our face. We want to be one step ahead. We looked at the public code repository. There was nothing like there. We need something to manage the herd. We need something to get insight into what's happening. This is where we created Red-Elk. There are multiple links in the slides where you can get the background information. On a more architectural overview, just to give you an idea where Red-Elk actually fits into our operation. On the left, you see the target implant on the target network. Normal operation, it connects back to our C2 servers via redirectors or reverse proxies and stuff like that. Let me try this one again. Simply doesn't work. Okay. This is where Red-Elk fits in. It's an Elasticsearch Logstash Kibana. It has all kinds of data indexes. It does enrichment of all kinds of data. It allows you to do searching. It has fancy dashboards. It gets its data from all kinds of data feeds coming from redirectors, traffic data and both the C2 servers operational red teaming data. It also copies stuff like screenshots, collected downloads from all kinds of C2 servers and things like that. It allows the white team and the red team to do easy searching with there, and this is where the fun happens. As soon as the target blue team starts to do some type of investigation, things happen. They cannot interact without leaving traces, so they start interacting with our redirectors. From their point of view, the implant connects back to a specific IP address or a domain name, and they start investigating in there. If you have insight into that operational traffic data, you get the same type of information as well. They also make use of public threat scanning security sources, security service providers, Spamhaus, VirusTotal, IBM X-Force, domain classifiers, all kinds of publicly available security vendors that give you ratings about IP addresses and all kinds of other stuff. The funny thing is, again, every contact leaves a trace. Those security service providers get that data by querying our infrastructure. So when we know a traffic that some VirusTotal things are happening on our redirectors, or IBM X-Force is again scanning our infrastructure, and if you have the possibility to have that insight, you're one step ahead. That's where the whole SEAM functionality comes into play. So we query those security service providers, we gather the data from all kinds of redirector traffic data, etc., and this is where we are one step ahead. Allow me to switch just to a different screen.
Yeah, you might wonder, why is it so important to have all this data in a red team operation? On one hand, an attacker gets better when he knows everything that's happening on his own infrastructure. So you can adjust to what the blue team does and how they respond to you. But also, as said, we're trying to service our clients. We want to make the blue team better. So also from a consultancy point of view, it's very important to have this data. So quite often we can phone the customer, meaning the board member that gave us the assignment, and tell them, we think your blue team is onto something, and if they dig hard enough, they might find us now within a few hours. So even if we deliberately expose ourselves to being found, we can still manage when and how we are found and inform the customer even before the blue team really escalates that an attack is going on, which helps us to optimize the exercise we're doing with that client.
Exactly, yeah. What you're looking at here is the Kibana graphical interface of a Red Elk instance. And it has a dashboard view, and it has as well a discover view. I will first talk a little bit about the dashboard view. It gives you in one oversight a proper oversight of the entire operation, like the amount of unique hosts you got beacons on, the host name, the systems, the entire period of operations, all kinds of different primary data that might be of interest. I talked about all kinds of alarms stuff. If I click on this area, it will give you an overview of the alarms that somehow Red Elk generated. And those alarms could be, as you see right here, make just the text a little bit bigger. We're talking about traffic, alarmed IP addresses over time hitting your infrastructure. It also talks about different files or different services which have a MD5 hash, and that MD5 hash got queried by VirusTotal, and VirusTotal or Hybrid Analysis said, well, yes, I am aware of this hash. If this hash is known by VirusTotal, and that hash is specific to our operation, and we did not upload it to VirusTotal, guess who uploaded that specific file? Well, the target did. So a pretty big alarm that something went on. There's also other type of data regarding your redirector, the traffic, or the different IP address that are accessing your infrastructure. If you provide the configuration to Red Elk of all the known IP addresses that are allowed to connect to the actual redirector infrastructure and are allowed to go to the C2 backend, all of a sudden a different IP address comes in, you get an alarm, and you can even deflect the traffic still on your redirector, but you still get the alarm giving you a heads up in that battle.
So you have to see that the URL our implants talk to is really unique. No one can guess that. It's only the implant that knows this URL. And when we start our engagement, any IP address is allowed to talk to our infrastructure. And as soon as we determine it's indeed the laptop of the victim, of the client, we will narrow down the IP scope that is allowed to talk to our infrastructure and being allowed in. And then if we suddenly see the same query from a total different area in the world to our infrastructure that only the victim can know, yeah, it's pretty clear that some investigation is going on, and an alarm is raised here. And if we deem it important enough, we usually also configure that we get an email stating that in our inbox saying, hey, your operation might be compromised, act now. And then we can choose. Sometimes we choose to disappear. So make a new C2 framework. If the customer wants us to play an aggressive but very sophisticated game, that's what we'll do. We'll just make that C2 channel, drop that, and move to the next, and we're still in the game. But also we have often customers say, oh, let them investigate, let them play around with it for 3-4 days, and then we'll reveal that a red team is going on. So it really gives us the steer in the operation on how we want to proceed with this attack and this test.
I switched to a different view, no longer dashboard. This is the straight discover interface of Kibana, and what you're looking at right here is what they call the Redirector traffic index. And right here I have filtered on a specific URL, which was, in our case for this example, this specific URL, the training beacon, and I have focused on a specific attack scenario. During an operation we have multiple scenarios running in parallel. This one is called Delta 12. So you see that filtered in here. There's a pretty standard view. You can open up such events, and in there, I'm just going to gloss over this just to give you an idea on the enrichment that we do. For example, because we configured our redirectors to put in extra data in there, we have, for example, all kinds of header information. We extract the user agent, we extract the X-forwarded fork, we extract the status codes, all kinds of different extra information that gives us more things to act on. So let's say we could exclude all the user agents which are specifically this. It's a simple interface. I just hit the minus mark, it does a re-querying, and all of a sudden I see all kinds of other implants or other systems that were connecting to the same URL in the same attack scenario with a different user agent, and it becomes interesting because all of a sudden we have different source IP addresses. This is more manual searching, but it does give you oversight if you have 10 different infrastructure traffic components, one central interface to see what is going on. There are multiple different views in here. I'm switching to what we call the Red Team Operations Index, and I've exfiltrated or filtered out some types of information. I just want to give you a quick overview in here. Let's open this event. Again, it says an attack scenario. It tells you for this specific implant traffic, it is for this username with this host name, and this was the actual output of the message. Scrolling just a little bit, it tells us in this case that the C2 program is Cobalt Strike, and this was the output that the implant gave back at that time. If I scroll down a bit, there is more type of information shared here, the external IP address, geo IP information enriched from there. It has all kinds of information about the Windows version, all data that is within the logging of your C2 framework. Quick oversight. There are multiple views, but sometimes you just want to have easy access to the full implant log file. That's why there's an easy direct link to the full log. And here you have, I'm not asking you to try to read this, but it shows you the raw beacon log file. And here on you can just hit your typical Control F, and you can search to the specific thing that you want within your.
This output, by the way, is a Cobalt Strike implant. I guess, I hope most of you are familiar with Cobalt Strike as a red teaming tool. Either though the GUI is quite responsive, searching back in data for a command that you commissioned 8 hours ago or even days before usually is a hell. So as a red team operator, we're also working in Red Hat constantly during our gigs. Because why execute a command if you already executed the same command yesterday and you can simply look it up?
Yeah. We use this Google-like interface pretty easily. I do not know if which specific beacon I entered that specific command, was it ABC or one of the other 20 beacons. This is one centralized view, simple, quick query style. There's a few more different types of views in here, easy to use. It's a quick overview of all kinds of C2 credentials, all downloads, all specific IOCs. You go to that, you click the download generate report, and you get a full overview of all the IOCs of your operation, screenshots, keystrokes, all kinds of, as well as what we call signals. And here it gathers the specific MITRE ATT&CK T numbers that you can plot into a navigator interface and tell your blue team or your white team what was going on. Nothing new here. This is default tooling that was existing for quite some time. Indicator of investigations is how we like to call them. Let's say if we make a division between the direct actions to our infrastructure, we can easily get alarms for, let's say, rogue user agents, blue teamers using curl or the Python command line stuff to investigate our infrastructure. Boom, immediate alarms if that happens. Rogue IP addresses, like I already mentioned. Deflected traffic, if you have your redirector with some smart logic in there, deflecting to a certain endpoint with an alarm tag in there, you get an automatic alarm. And if you have a range of known IP addresses of blue teams, you can put it in there. Any action coming from known blue IP addresses is immediate alarm stuff worthy. Indirect, more talking about security service providers, let's say the antivirus hash or the MD5 hash of a file, but also blacklisting of IP addresses of our infrastructure and domain classifications if it changes, things like that. Immediate alarms, this is basic SIEM-like functionality. I see we missed with 3 minutes, so the timing. Awesome. Yeah, let's go back to the current time. We made some additions to Red Dot because, well, we started thinking, if we've been using this in operation with happiness, we're using it to give better oversight and better insight. We want to optimize our operation and we want to do more stuff to detect blue. Let's look at how blue has evolved over the last few years. And if you look at how blue teams operate, or SOC or whatever, they generally progress over 2 main axes. One, more data. Just connect more data sources. More is better, is bigger, it's all good.
Maybe something to mention there. Are there any blue teamers in the room here?
Of course there
Some
are.
hands? Yeah. I must say that I'm surprised with how aggressively and fast the blue teams have progressed over the last few years. So kudos for that. It's really going fast and making how our operations and actions and the criminals' actions a lot harder, which of course is the goal in the end for the blue team. So.
You can call it detection engineering, threat detection, whatever, just connecting more data sources. It's easy for us with the Red Dot concept. Another area which is really interesting is what they call threat hunting, a more of a hypothesis-based approach to catch, well, known attackers that somehow slipped through current defenses. It's a bit more free format search. You require different tools if you put it into our perspective. So that's what got us thinking. Remember this image? We added a few things. On the left side, we have added the ability to do more queries on the implant side, more queries on the inside of the attackers or the target's network. And on the right side, you see 2 things. Neo4j, allowing you to import the output of BloodHound for attack path measuring within your target, and also Jupyter Notebooks, allowing you a bit free format more searching in all the different data sources that are out there. And that's exactly what Marc will be telling you.
First, before we move on, I want to see some hands. Who does not know BloodHound? Because then I'm going to explain what it is to keep you on board. Is BloodHound a familiar tool? I see a few hands. Who is familiar with BloodHound? Then I expect to see the rest of the hands. Cool, yeah, okay, gives me an impression. I'll try to do a very short introduction. BloodHound is a tool developed by SpectreOps, if I'm correctly, yeah. What it does, you drop some code in the customer's network, and this code will start querying Active Directory. So it will gather all data it can on users you have, groups you have, sessions that might be there, so people being logged on to machines, information on these machines themselves, and so on and so on. It gathers all this data, basically your whole Active Directory, puts it in a database, and you can ask it to draw a path. So you can ask it, I've got this user, I want to go to domain admin, is there a path in between? And if there is, it will say, yes, there is. This user has local admin to that machine, where there's a session of an admin, who's also admin to this machine, and on that machine, there's a domain administrator logged in, and if you steal his creds, you're domain admin. So that's roughly what BloodHound does. Gathers data and allows you to draw a path from point A to point B.
A different way of saying that is Google Maps-like navigation within a target network. I'm here, I want to go there, I've got this information about possible routes, just bring me to it.
Yeah, so BloodHound has a lot of data on what paths could exist or are existing in the network, but you don't have the starting point yet. But Red Elk, on the other hand, has a lot of information live during your operation. On every step you make, on every command you type, BloodHound knows about that. So if we combine this combination, you get sort of a golden marriage, and we're trying to go there in a bit. You don't have to read this all. It's just in Cobalt Strike, someone types PS, give me a process list. And this process list shows a lot of processes, including one of the user A. Janssen. And you want to know, does A. Janssen have, by any means, a path to domain admin? Because if he has, I'm going to inject into that process and walk down the path. And I'm domain admin. That's the goal where the technical red teamer at that point is. So what do we do? At least what did I do in the past, and I expect most of you. You copy and paste A. Janssen into your BloodHound interface and see if there's a path. And there might be a path, there might not be a path. Next, you land on a Citrix machine, and there's 25 users there. Does that mean you really have to spend the next 1.5 hours copy and paste usernames to see if there's a path from one of these processes to the main admin? Is that why we became red teamers? We thought not. So we decided, as mentioned here, I'm not going into the details there, we didn't only include Neo4j, we also included Jupyter notebooks. Basically, a web interface where you can run cool Python snippets. It's way more than that, but for this talk, that will be sufficient. So we thought, let's see if we can make it work together. So let's make Red Elk and BloodHound play together. First, we note these Jupyter notebooks, where we can write snippets of code. Then we write a small snippet of code that says, connect to Red Elk and allow me to run any query. Then we write another snippet of code that says, connect to Neo4j, the graph database behind BloodHound, and let me run any query. And then you write a query. I'm not good at writing, so I'm really happy you cannot read this source, because I'm not a good developer. There's a reason I quit that job quite early in my career. But hey, it works. So first we query in Red Elk for all PS commands. So we'll get a lot of lines back with every line that includes a PS. We parse all of these lines, so just some hacking and string, cutting it up, putting it in a table. And once we have a very structured way of showing all the PS or all the processes in all the PSs we've done so far, we can then for each of these lines, for each of these processes, run a query against BloodHound, seeing is there any way that we might have domain domain admin already. So first, the first query is at 0994, A. Janssen, nothing found. You move to another box, or something changes on the box, you run PS again, and the tool for you will just run this path. Second round, nothing found. Then you move to another box, and you find admin-A Janssen at strobe.local, and voila, it will alarm you straight away, domain admin is found. Maybe with this name, it's quite obvious, but quite often you can find really obscure paths with BloodHound, and I think in 99% of the times, this tool is way faster than us doing copy-paste into Neo4j. So that's one way and one addition we brought to Red Elk. And as said, what our goal is with Red Elk is, one, to optimize our operation. I think this was a clear example of optimization, where you can perform your red team better and faster. But there was another important thing, detecting the blue team. We want to detect whether or not the blue team sees us doing stuff, so we can either adjust the course of the attack, or we can inform the customer management saying, they are onto something good, that's a good learning experience, what do we do now? What do you want us to do? So let's dive into that. How can we detect if blue team is onto us? One of those might be a reset of the KRB TGT. Not necessarily we have it already, the golden key of the domain controller, so to say. Not necessarily we have it already, but if they get nervous, domain admins, they have a tendency to change their own password and change the password of other important items in the network. So if that suddenly changes, that might be a very clear indicator that something's going on. What you see here is the PowerShell to request from the domain controller what this reset date is. And we decided to build our own DLL, our own piece of C code that does the same thing through the Active Directory service interface, ATSI interface, which is quite safe to query, as it's really hard to detect such a query. And we can ask out, for example, KBTGT, but also all the members of domain admins. And if you have a rough idea how long these passwords are valid, and if someone changes his password halfway, that might also be a reason to be alert. Like, I'm doing this move, I just compromised this account, and there's one admin suddenly getting shaky and changing passwords. It doesn't mean we're detected, but at least it means we have to be on high alert as well. So we wrote some code around that as well. So first, we prepare ELK, we prepare Neo4j, and we download all the security tools that have been queried, because you can run this kind of blue checks, you can run them all the time. We also have a similar DLL written not for password changes, but for security tooling. So we query on a system what kind of security tooling is present. Usually it's an AV, there might be some EDR tooling present, and we take that as a baseline. So we do a first query, and what we find in the first 1, 2, or 3 hits, and if they're similar, we take that as a baseline. And then we keep the code running, and as soon as we see extra security components pop up, then we need to raise an alarm.
Trying to enhance the zooming just a little bit.
Yeah.
Things like Defender, things like all kinds of sysinternal tools, things like that.
So first, the baseline we set was System Activity Monitor and Windows Defender Smart Screen, and over time we see there's nothing new there, and then suddenly a new tool is found, the Sysinternal Process Explorer. And that's a reason to raise an alarm, like saying, hey, we've got sysinternal on the machine where you were performing actions. The blue team might be on your tail, so act accordingly. And there's a third example, which we haven't written out yet, but we're working on that. Another thing we quite often see, that if we do stupid stuff, we make a mistake on a laptop or on an end-user device, they tend to, one, isolate the machine, so completely block it off, or sometimes they tend to move the machine behind a proxy so they can do SSL inspection, trying to figure out if and what kind of C2 channel is being built to the outside world. Another reason might be that might be that they won't pick the whole machine and put it behind a proxy, but they found either our persistent code or the initial code we used and put that behind a proxy as an investigation. So one of the checks is check the certificate. So do one ping to do one reach out to a domain name, check for the certificate that's on there. Keep that in mind, and as soon as we see the certificate change, raise an alarm. Apparently someone is playing around with the stuff we put out there, and that might be a valid reason for us to stay on high alert. An investigation might be our way. So we got a few more tricks up our sleeve for the upcoming time. Password resets, we mentioned that. TLS interception was mentioned. Security tooling was mentioned. Log forwarding. If we suddenly see a change on one of the systems that we're on, where logs are either forwarded somewhere else, or more logging is enabled, that's also a reason for us to stay on high alert, because there might be some changes at hand. Changes of security config is also a reason to stay on high alert, and accounts login. If we suddenly see a local admin log into a machine where we've been messing around, that might be a clear indicator that someone is trying to do some investigation. If you're in a blue team, though, be aware that logging in with a high privileged account to a machine that you consider owned is the same as giving away that account. So take care there and don't do that. But if you do, we'll likely see it.
Think of the whole tiering aspect, the tiering architecture that Microsoft has put out, as well as the clean source principle. Never log on to a lowered tier system, because you will leave credentials on that remote system, on that untrusted system.
So after giving you a lot of information on how we progressed as Red Team, I think it's time also for a shout out and a thanks to the Blue Team, because we were merely looking at the techniques you guys deploy as a Blue Team and how we can mimic those. Because there's a lot of lessons learned in the progress that the Blue Teams make, and we just want to copy what Blue is doing. So take the concept they're doing to get insight in their environment and do the same, at least on the machines we own, by the time we are halfway during the operation. So I think here's a list that we see happening on the Blue Team and how we want to implement those. One is sending samples to the cloud for analysis. That's a cool thing, and that's also a heavy measure against any malware that's reused, because if customer A submits it to the cloud already, an attacker cannot reuse the same malware at customer B, because the cloud will already know it's evil and kill it straight away. Heuristic analysis, so behavioral monitoring. That's also what we're trying to do. We're trying to monitor the hosts we're working on, and if one of them pops out and for some reason, that might be a reason for us to be more alert. Application whitelisting, very common technique on the Blue Team part. We're doing the same on our side. We have whitelisting on either the C2 channel and the IPs that we allow in, or even on giving out our payloads. If there's a payload on a web server, you would only be allowed to download that if you come from a range or if you send a query that we expect. We don't want any random sandbox downloading our code all the time, because that wouldn't work. And I think last on the list is artificial intelligence. That's a buzzword, guys. We're not going to implement on the Red Team side.
I'm pretty sure that even the Blue Teams have not successfully implemented it.
Yeah.
So, yeah.
I doubt it. I highly doubt it. So the summary of this talk, I think most important is, and people, everyone, to the Blue Teams and the Red Teams in this room, remember, the goal of the Red Team is make the Blue Team better. Yesterday at dinner, I got asked, if you do your best to be just below the surface and give the Blue Team a chance to detect you, don't you consider the Red Team failed if they catch you? Hell no. I consider the Red Team failed if the Blue Team learned nothing. It doesn't matter if I get caught or not. The end goal is the Blue Team being better. The bigger end goal is the company not being ransomed in half a year. So essentially, Blue Teams and Red Teams are not against each other. There might be some angry faces now and then, but that's like a strong soccer match. Sometimes a bit of pain is needed to improve. But the Blue Teams are there to serve, the Red Teams are there to serve the Blue Teams in getting better. And please, Blue Teams, if you feel you've got a Red Team on the other side that's only punching you and never gives you anything back, report it, work on it, improve that. And if you're a Red Team and you think you fail if you get caught, forget about it. You fail if the Blue Team doesn't learn anything. Keep that in mind. And ask your customer as well. If you do a Red Team engagement, the query at the beginning should be, what do you want to learn? What do you want me to simulate? If you do Red Teaming with Outflank, you don't want to know if Outflank can break in. I can almost say we're confident that in most cases we can. No, you want to learn if an average ransomware guy from a certain area in the world can do a very aggressive attack and succeed. Or maybe you want to learn if a very skilled adversary that takes 5 months and builds his own tool can make a persistent connection and listen in on your data over the next few years. Two totally different questions, two totally different approaches for the Red Team, for us. And still, it's important that we mimic what the customer asks and stay close to those adversaries so the Blue Team can improve. The Blue Team is not there to kick out the Red Team. The Blue Team is there to kick out the criminal. So please keep that in mind. Red Elk is here to help you for the Red Teams, but in the end also for the Blue Teams, because in the end of the operation, we can give the Blue Team a list of every command, when we did it, how we did it, what the parameters were. And they can tune their defenses to make sure that next time we do such a thing, it's detected. So that's one.
Go to GitHub, check on the alarms, code that's in there, just the simple checks that we can do to spot the traces left by Blue. It's for your knowledge as well. But essentially, Red Elk is, of course, created for Red Teams. It's here to help you. And as a Blue Team, most of the tools you can just download and repeat the steps. Do it yourself. Make sure that the alarm triggers. How waste would it if a next Red Team can do the same trick and still succeed? And then the IOC overviews from Red Elk. Quite often, either during the operation, if management gets stressed that some real attack might be going on, it's a piece of cake for us to check, was that us? Give me a username, give me an MD5, a file name, anything, and I'll look it up and I can tell you exactly whether or not we touched that machine during our op. And in the end, while cleaning up, the IOCs also really help to clean up the stuff that might be left behind.
quite often we find leftovers from other red teams. Clean up your stuff, and if you can't, ask the blue team to do so and give them the information they need. And then, of course, blue team, think of your OPSEC. If we can monitor what you guys are doing, the criminals can as well. And we might use Red Elk for the benefit of the engagement and for your benefit. If a criminal would use something like Red Elk, it's not going to benefit you. It's only going to make your life harder and the attack more advanced.
If we have to give a penny to every blue team that tries to investigate a certain URL of our C2 implant, by first accessing it with the actual implant and then trying with Python from the same IP address of the corporate network and then switching all of a sudden, going to Tor. And we see traffic coming in from Tor to that specific IP address. Please think of your OPSEC.
Don't send the URL by WhatsApp to the team members. WhatsApp will query the URL and we'll see WhatsApp coming in, okay? Someone found our C2 URL and forwards it to a colleague. Please don't.
Okay.
I think that's it for now. Any questions?
We still got a few minutes left, so...
If not, we're going to give the 5 minutes that Win saved us to the next speaker, and he can use those. I see it's just ready.
Do you support other C2 infrastructures or only CobbleStrike and Beacon? Because Beacon is getting caught a lot.
Yeah. The question is, do we only, which C2 frameworks do we support? Actually, well, CobbleStrike is a very big one that we support. We have our own C2 framework, which we support. We're working on several others, which have partly support, like Posh C2, and I'm interested in, I have basic support for Mythic, and I'm looking at Sliver as well. But it's an open source project. I'm welcoming any type of help on this.
Any more questions? Either I was that clear or I was that boring. Thanks a lot for your time.
We will be around for the remaining of the conference. If you still have questions, hook us up somewhere in on the outside. Thank you all for your attention.
Thanks.